Question 12, Part E. The diagram shows the graph of y equals 1 over the absolute value of x minus 5. For what values of x is x over 6 greater than or equal to 1 over the absolute value of x minus 5? Find critical points by solving as an equation x over 6 equals 1 over the absolute value of x minus 5. What we're finding are the points where the line x over 6 meets the hyperbola 1 over the absolute value of x minus 5. A couple of points to note here. Firstly, x cannot equal 5 since the denominator of the right hand side cannot equal 0. Also, the right hand side is positive because the absolute value of x minus 5 is greater than or equal to 0. So the entire fraction must be positive. And we know that x minus 5 cannot equal 0 or else we'll have division by 0 occurring. So if the right hand side is positive, that means the left hand side must also be positive. That means x itself has to be greater than 0. This will become important a little bit later on. Now, because we're solving an equation involving an absolute value, this gives rise to two cases. We have a positive case and a negative case. Let's consider the positive case, case 1. X over 6 equals 1 over x minus 5. By cross multiplication, we can form the equation x squared minus 5x equals 6. Moving the 6 over from the right hand side over to the left hand side will form a monic quadratic equation x squared minus 5x minus 6 equals 0. And that factorizes to x plus 1 in brackets times x minus 6 in brackets equals 0. And by the null factor theorem, we have x equals negative 1 or x equals 6. But we stated earlier that x has to be positive. So we'll discard x equals negative 1. Let's consider the negative case, case 2. So we have x over 6 equals negative 1 over x minus 5. So we'll repeat the same thing that we did in case 1. By cross multiplication, we can form the equation x squared minus 5x equals negative 6. Moving the negative 6 over to the left-hand side becomes positive 6. So we'll form the monic quadratic equation x squared minus 5x plus 6 equals 0. And that factorizes to x minus 2 in brackets times x minus 3 in brackets, and that equals 0. And by the null factor theorem, we get x equals 2 or x equals 3. Hence, the four critical points are x equals 2, 3, 5, and 6. Now that we have found the critical points, we need to test the inequality around the critical points either algebraically or graphically. I'm going to test the inequality graphically by sketching the line y equals x over 6 on the existing graph that's given in the question. Let's have a look. So this is the graph that's supplied in the question. This is the graph of y equals 1 over the absolute value of x minus 5. We can see that it's a type of hyperbola. It has a vertical asymptote at x equals 5, which happens to correspond to one of the critical points that we've found earlier. Now the line y equals x over 6 is a line with a positive gradient passing through the origin, and it intersects with the hyperbola at 3 points, which correspond to the 3 other critical points that we found at x equals 2, x equals 3, and at x equals 6. And we're interested in the intervals of x where the line is on or above the hyperbola. And that occurs between x equals 2 and x equals 3, or on or after x equals 6. So from the graph, x over 6 is greater than or equal to 1 over the absolute value of x minus 5 in the interval x greater than or equal to 2 and less than or equal to 3, or x greater than or equal to 6.